In this lecture, we are going to write an array of data on a specific memory location in our EEPROM, and we are going to read the same data and we are going to display that data on the hyperterminal. Okay, so basically we want to write an array. So the driver functions for writing and reading the data to and from the array are already defined, okay, in the previous lecture. So in this lecture we are going to implement those functions. So first of all, what do we need to do? So this is your old program that is for transmitting and receiving a single byte, okay? So you can make changes in these functions only. So what are you going to do? So first of all, you have already initialized your SPI and UART, okay? And you have already used or configured the status register also, which helps us to disable the write protect for the whole EEPROM, and so that we can write the data into the EEPROM, right? So now what we are going to do is we are going to use this function EEPROM write array. So what are the arguments that this function takes? So the first argument that it takes is the EEPROM address, the address at which we want to store our data, then the array data, then we have to put the array that we want to transmit or store onto this EEPROM address, and here the length of the array will come. So I will just copy this, okay, and I'll paste it in my main routine. So this function is not needed, okay. I'll paste it here. So basically the array data, we don't have any array data as of now, so we will have to define the array first, okay. So what will it do? So first of all, here we will define an array, that is two arrays we will define, that is data underscore tx, the array which we will transmit, and we will make an array of 2 bytes, that is 16 elements, okay. And another array will be data underscore rx, again of 16 bits, right. Now what will we do? Now here we will put data underscore tx, okay. And here in the length, what length will you put? So the length here will be, we will use the function, library function size of, okay. So using size of and in the braces data underscore tx. So whatever the size of this array is, that size will automatically be defined here, okay. And the EEPROM address, let us take it as 0x0000, okay. So this is it. The array, the arguments are passed, but still we don't have our array data, right? So what data will we put? So here we can do one thing, is we can configure a for loop of 16 iterations, right? So I will configure a for loop of 16, that is, so I equals to 0 and I less than, I can put size of uh, data underscore tx, okay, and I increment, all right. Okay, so what will we do? So first of all, we have used I here, but we haven't defined it, okay. So we'll have to define it first. So I will put I also here, I comma, okay. Now the I is defined. Now what will we do is, so in the 16 iterations we will store 16 numbers right from 0 to 15, okay. So in the data underscore tx, and in the ith element we will store the data I, all right. So 16 elements will be stored into this array, that is 0 to 15. So now our aim is to display transmit 0 to 15 on this memory location, that is 0x0000, and we have to read the same data from this location and then display this on our teraterm screen. Okay, so now our array is filled with the data and our EPROM underscore write underscore array function is also implemented. Now the array is transmitted. Now we want to read the same data. So for that we will use the function uh, EPROM underscore read underscore array. Okay, so I will just copy it and we will remove these both functions and I'll paste it over here. So in this EPROM address, the same address will go, that is 0x0000. Okay, and in the destination address we have made another array, that is data underscore rx. Okay, so the data that we will read will be stored in this destination address or in this array data underscore rx. Okay, and the length will be of size of rx, the size of data underscore rx, data underscore rx. All right, so now this will read the data uh, that is received on the SPI bus. Okay, now the data is written as well as read. So in between them, let us put some delay, that is hall underscore delay, and let us put delay of 10 milliseconds. Okay, now the data is read. Now what will we do? Now we have to transmit our data. Okay, so for transmitting our data, so here we have to transmit our data 16 times because our function hall underscore uart underscore transmit, that won't display the whole array at a time. Okay, so here also we have to transmit. So what will we do? So here also I will use a for loop. Okay, so I equals to 0 and I less than size of data underscore rx. All right, and I increment. Okay, so in here what will we do? So we will use this function only, hall underscore transmit, and paste it here. So we will when this iteration will start executing, then the whole array will be displayed in a line. Okay, so we don't want that. We will on the contrary, we will what will we do is we will display each data on a single line. So for that let us use the escape sequence for like this, that is slash r slash n. Now what does this slash r slash n mean? So this slash r is the escape sequence for carriage return, and this slash n is the escape sequence for new line. So carriage return is, for example, in this line your cursor is something in the middle here. Okay, so if I execute carriage return, then this cursor will go to this initial position, that is here. Okay, so wherever the cursor will be, it will go to the initial position, and this new line will be, it will take the cursor to the new line, that is here. So basically this slash r slash n will play the role of our enter button that is present on the keyboard. Okay, so here I will first of all I will execute this slash r slash n, then I will give some delay. Okay, hall underscore delay 100 millisecond. Okay, and after that I will transmit my data, that is here I will transmit my data underscore rx. Okay, now our function is complete. Okay, so this is our program, right? So nothing else needs to be done. So the connection is the same, hardware connection will be the same as we did in the previous programs. So here you just need to build your project. So click on this build. So your project is built, and now so let us open our flashing tool. So close the old X file, open the new one, go to the debug, spi.hex, build. So we need to connect our board here. So we will so connect, verify, and disconnect. Now open your Teraterm and set the appropriate baud rate, that is 9600. Okay, so now I'll press reset button on the board to execute. Now I have pressed reset button on the board and it is giving us some garbage value. Okay, so this is not the data that we wanted. So what is wrong with our project here? So the thing that is wrong here is first of all, the /r/n, it takes two elements. So here we need to put two, okay, not one. Each escape sequence is of 1 byte, okay, and the data received here, the size of the data, this array I have provided as 1. Okay, so this will also not work. And the third issue, which is the most important, is the data that is being stored into this data underscore rx array is in the form of character. Okay, and we need to, our Teraterm or our this hyperterminal utility, it only displays ASCII values. Okay, so what do we need to do is we need to convert this character data or integer data to the ASCII value, right? So for that we have a I have a ready-made function available for with me. Okay, so I will directly use that function which will convert any character or integer data into the ASCII data. So I will just say put this function over here. Okay, so I to a means integer to a. Okay, so here the first argument you need to put the number that you or put the data that you need to convert to the ASCII, right? And this is the pointer to the output string, right? So first of all we need to declare this function on the top of our page. Okay, here I will declare this function over here. Okay, and then I will have to make another variable by the name let's say converted value. All right, so I have made another variable by the name converted value. Now what will I do is I will use this function. So I will copy it and I'll paste it in this for loop. Okay, and here in the input I will put this data underscore rx. Okay, so this is the data that we need to convert. Okay, and in the bracket I, and in this other argument I will put the converted value, that is and converted value. So whatever data will be converted will be stored in this variable. All right, and here we need to display the data converted value. Okay, now our function will work. So now what we basically did is whatever data we will iterate through this for loop, so that data on that particular element will be converted to ASCII and it will be stored in this converted value variable that we defined. Okay, and that variable we will define every time, right? But there is another issue. We are going to display our data from 0 to 15. So till 0 to 9 it is okay. It will be only, the data will be of 1 byte only. But from 10 onwards till 15 it will be of 2 bytes. Right? So this converted value needs to be of 16 bit, or we will make it an array of 2 bytes. Okay, so we will assign 2 bytes to it. Okay, and let us keep this array empty. Okay, give it a value 0. So now this will work, and here the length will be of 2 bytes, maximum length. So now let us save our project and build our project. Now open your flashing utility and close the previous X, open it, select your hex file, connect, program and verify, and disconnect, and just clear the buffer and press reset button. So now on the screen you can see that array data from all the way from 0 to 15, that is from all the 16 elements on the new line, is being displayed with the delay of 100 milliseconds. So in this way we write an data in an array in the EEPROM and read the same from it and display on the Tera term using the SPI protocol.